I think essentially like one thing I think will probably emerge soon that will really surprise people is situational awareness. Like models will understand that I am a model, I am being trained on this thing. Actually, like if I read these particular articles on the internet, I'll figure out like I've actually been trained on this data and I'm trained in this way. And eventually, if models have access to like develop themselves or like write code to like improve their own efficiency or things like this that are probably very productive and make frontier labs a lot of money. This can be incredibly dangerous.
Gatlen, Riya,
Yep.
welcome. Good to be here with you today.
Good to be here as well.
Very excited for this.
Absolutely. So a lot of the episodes of my podcast and Discovery Engines have been around how AI is going to help with scientific discovery. The flip side of AI becoming increasingly powerful in that domain, for example, is that it also introduces new risks, both in science, but also as it's interwoven into AI agents and into commerce and social media and other platforms. Whether on one end of the spectrum, biases that we may not understand, to on the other side of the spectrum, there are books that have come out like if anyone builds it, everyone dies, right? The existential risks of super powerful AI. And so one reason I'm super excited to be chatting with you all is that you, as undergrads here at MIT and as board members of MIT's AI alignment group, are really focused on looking into these questions and helping us kind of better make sense of them, providing really cool training and other great things which you're going to tell us about. So really appreciate your time and ability to have this conversation with you.
Yeah.
Thank you.
So since you're both board members of MAIA, let's start there. Tell me more about kind of what MAIA is as an organization and what its mission is.
Yeah, I would say MAIA, or MIT AI Alignment, has focused a lot on becoming like the kind of central hub around MIT for talking about AI safety, both in the sense of like talking more about AI safety, why you should care about it, kind of doing advocacy on that level, also like skilling people up and understanding like the technical aspects of AI safety. We focus a little bit less on policy, unlike our counterparts over at Harvard. And also try to connect people with like labs that are doing AI safety research, as well as nonprofit organizations also doing like AI safety research, including like I guess like the capability labs like OpenAI and Anthropic, like helping people get onto like safety teams and do like good safety research.
Got it.
I'd like to say that like the goal of MAIA in my mind is to basically interact with all the students at MIT and broader, help them figure out if they're interested in AI safety, and if so, get them a job in AI safety.
How did it, AI safety is getting a lot of, I would say, a lot more attention, especially in the last year or two, as these AIs become more ever-present, more powerful. MAIA's been around for a while, so like, what was its origin story, and how did somebody decide that this was an important thing to focus on?
Yeah. So I've been in MAIA for quite a while. It's been about like 4 years now. Senior took a leave of absence, so like I got to see like the very beginnings. I was kind of interested in AI safety even before like ChatGPT came out, and so I'm kind of familiar with like the original founding group. There's been a lot of like AI safety university groups kind of across the world. I think like Stanford's was one of the originals. But yeah, there was kind of a group of people that cared a lot about AI safety, mostly from like, I guess like a theory of like what happens when you get really powerful agents out there in the world and what kind of dangers arise from that. And they ended up founding MAIA, and that was about 4 years ago, and it's kind of been consisting of that like today, handed down generation. Yeah.
And like, what was maybe the personal kind of turning point for you, where you were said, like I should pay attention to this, right? We hear a lot about kind of like the fun things that you can build with AI, but I feel like there are fewer folks who get excited about the other side of like, how do we make sure that this is safe? Very early in your academic careers and kind of professional careers, you've decided, hey, this is worth spending my time and effort into researching. So I think for you, it started in high school. Is that right?
Yeah. So actually, in high school, I was doing a lot of that sort of AI engineering sort of work, where I was kind of interested in the question of like, what could we like? I mean, the thing that we're all trying to answer today, right? What can we build with AI models? How can we like integrate them most interesting ways into like healthcare, climate, et cetera. Like I was working on developing AI systems across a ton of different domains. And I guess something I stumbled upon when doing research in high school was the fact that from anonymized medical images, AI models, particularly like vision models, can learn to predict demographic information of patients. So for instance, from an image of your like eye, like a retinal scan, a model could predict like your race, your ethnicity, your gender, and your age within some like region of error. And this was just extremely surprising to me. And this ability is like not even like kind of random. Like this ability is like models have nearly like perfect accuracy on this task, despite like entire experiments where I degraded the medical images to the point at which they no longer looked like medical images. There was just so much signal contained in a medical image that has to do with humans. And AI is like this master pattern recognition tool. It can pick out a lot of this. And I mean, initially my thought with this sort of this finding that I'd read a paper about was this is just extremely dangerous. Like you can imagine worlds where AI models are taking into account this information and making downstream predictions without humans knowing it. And that may or may not have been true. In fact, we found in most cases it's not true. But still, like this was an incredibly dangerous initial insight. So I kind of came into MIT having done this research in trying to understand algorithmic bias. And I actually joined MAIA's AI Safety Fundamentals course, which I think is a wonderful course that really focuses on upskilling new people in safety. And as a result of this like 6-week program last year, I kind of got an introduction to like risks beyond just the bias risks I'd been previously worried about, but in fact like existential level risks and why we should care. Whether or not like, our timelines for existential level AI are like, 5 years, 20 years, our lifetime, whatever. I still found that there was like enough reason, enough worry for me to work on this right now and in the present. Definitely like what got me into safety was first that course and also like previous background being sort of like pushing me in this direction of like, we really need to think and understand what's going on under the hood of the models because currently we have no clue and this just makes them dangerous.
Wow, it's amazing how much you can extrapolate just from a retinal image.
Yeah, it was crazy.
Yeah. I heard a talk last year or earlier this year by Yuval Noah Harari, who also talks a lot about kind of the future of AI and humanity. And he talks, I think one of the themes he says is, AI might know us better than we know ourselves. Yeah. And so I think one of the examples that he used was, for example, a camera that studies your facial expressions and micro expressions and maybe pulse and so forth, and is then able to target advertising, right, to you, or maybe worse, right, and sort of some sort of Orwellian, if it's like in the power of the state. And so I'm hearing a little snippet of that with, gosh, just from a retinal scan, you can use so much information or get so much information that can be used.
Yeah. In fact, there was a paper in Science, I believe, that basically found that there was a critical algorithm deployed to over 300 million Americans. This paper was from 2021, I believe, that actually performed significantly worse on patients of color. And the reason for this was because it was accounting, this particular algorithm was used to help prescribe medication to patients. And one thing it accounted for in prescriptions was the amount of money someone spent annually on healthcare. And people who were from underrepresented communities spent less on healthcare, which led the model to believe they were more healthy, when in reality they had less access to healthcare opportunities.
Wow. Okay, great example of bias there. Gatlen, what was the story for you? How did you get interested in AI safety?
Yeah, so again, I got into it like quite a while ago, like before like ChatGPT and all that. I think I got into it first from like the idea of like what would actually be the ramifications of like actually building like a super intelligent AI. So like even if there is like a small probability of this happening, like 10% in the next like few decades or something like this, like I think the ramifications of that would be quite like massive in terms of just like, for example, my alternative would be to like work in like maybe physics. Like I was very interested in physics research. And I think the idea of like, super intelligence that would be able to like run a bunch of experiments, do a lot of like theory work, etc., would be able to like do a lot of the things that I am doing as well. So I was just like, oh my gosh, like any of the progress I'd be doing would just be kind of speeding up things just like a little bit further. And so it seemed like from this point, it's like superintelligence could do a lot of good. Superintelligence could also do an incredible amount of bad. And it seemed like this was a very pivotal technology that could be developed over the next few years, like next few decades. And I was like, wow, I just want to like make sure that this goes pretty well. Yeah, so there was that aspect, and yeah, I would say like I have branched out since then. Like I don't just think about like superintelligence, but I feel like there's so many other like smaller ways that like AI could really shape society in the next few years, and that these are like really important to work on.
So as board members of MAIA, as folks who took this AI Safety Fundamentals course and are continuing to do events and training and so forth, I'm curious, what themes are you seeing in the kind of members that are joining, and have those themes shifted or changed at all over the last few years?
I think one thing really exciting about AI safety, both in the technical and policy landscapes, is that there is simply like so much low-hanging fruit. This is also true of AI capabilities work, and is one reason that we feel that the field is going to continue progressing forward and we're going to keep getting smarter models, there's still like so much like work to be done that is like, people who are new to the field can do and make like progress in like ways that are like pushing the frontier. And that's definitely something like you see attracts a lot of really intelligent people to MAIA, because people see that this field is like not only like incredibly important and exciting, which hopefully we're trying to convey, but also there's just a lot that one can do without much experience that can truly be like incredibly like meaningful for safety, for like the future of humanity as we see it. And yeah, I think that definitely like shapes the members that we get. I wonder, like, I mean, how has this changed? Have we always had such like, I don't know, exciting, enthusiastic people who are like, I don't know, like, yeah, super technically talented as well?
Yeah, I'd say we always attracted like a very like highly skilled group of people overall. And I think like one interesting trend that we've also seen is just like as AI has just like advanced dramatically, including with like mathematical capabilities. Like we have a person who has recently just joined MAIA who was like top 5 or something in like International Math Olympiad, like Physics Olympiad, like IOI, and like things like this. So like they joined MAIA because they saw like AI being able to reach the point where it was able to reach gold, like get gold medals in the same domains that this person thought that they were like uniquely well suited for. And they're like, wow, like this seems like a really important piece of technology, and like the implications of this like has not been felt. So like we get like important people from that aspect, and then we also get like people who kind of get, we call it kind of like getting nerd sniped in the sense that like there's a lot of really interesting questions within AI, a lot of really low hanging fruit, and there's like people who are really interested in math like love this.
Yeah, one thing is like, especially for mechanistic interpretability, I mean, it's all about opening up the black box of what's in AI model's head. And there's like a lot of, fundamentally a model is just a ton of like linear algebra operations, but in reality there's a lot of much more confusing like interactions and things that go on that are super hard to explain. And so I think like many people who get into mechanistic interpretability particularly, or MechInterp for short, kind of are, have played around with AI models themselves and are like, this is so weird. Like I can just like remove a layer, I can like add in this like random thing, I can like totally like mess with my data and the model still performs just as well. Like what is going on here? There's this kind of like sciencey question of like, can I understand what's actually happening? Because this is like, it's really weird that my classifier works this well. And so we definitely get people in MechInterp from that sort of like curiosity to understand what's going on underneath this like thing we see everywhere.
Well, so you mentioned mechanistic interpretability. In my sort of early research into different techniques in AI safety, some of the approaches or maybe like interfaces to these models are things like chain of thought reasoning. There's the area of model observability, token level attribution. You mentioned mechanistic interpretability. I've heard some talk of probes as well. Could you maybe just like share kind of on a technical maybe perspective, kind of what the landscape is of sort of the primary techniques for AI safety and where maybe MechInterp fits in with that?
Yeah, totally. So, I mean, AI safety is incredibly broad, and there's both like technical work that's important, policy work that's important. I would say like in the domain of technical work, there's kind of a few key areas that I think are pretty important. So the first one is this idea of like, MechInterp. Like, can we figure out what a model is actually thinking? Because models produce outputs, but like, what's actually going on in the intermediate steps? Can we figure out like predict they're going to like, I don't know, make some decision before they make it? That's what kind of the goal of a probe is. Can we like, do other tasks like remove certain like abilities from a model? Can we like do unlearning sorts of things? And then there's kind of this related area, but different, called control. The idea behind MechInterp is like, let's understand what our super intelligent or maybe like, frontier models are doing. But control is like, okay, let's say we have like really intelligent systems, but we have no clue what they're doing. Can we still be safe? Can we put them in setups against each other where we can kind of limit the danger that they provide? And so this is like these two definitely go hand in hand. I mean, one way I kind of see it is that control is kind of buying time for MechInterp, because MechInterp is like incredibly slow. Like it's just an incredibly hard field in the sense that we have kind of like no idea what the right direction is, one, and two, trying to understand what goes in the model's head is like very expensive and very time consuming and requires a lot of effort. Especially as models get bigger. We need to like perhaps study like every individual neuron in a model, or do things like try to figure out like which sort of like reasoning traces, like which sort of like neuron traces through the model correspond to like particular skills and abilities a model might have. And doing this requires a lot of experimental work. And especially as like, models become larger, this becomes more expensive, more time consuming. And then control work, on the other hand, is something that we can like build on and work on with like model APIs. And so kind of like scales a lot more nicely in this way. And so like, I think that perhaps, eventually we'll solve MechInterp, but I think before then we definitely need control, and probably after then we also need control. So yeah, that's like one way I kind of see those two fitting together. Another kind of related field that a lot of technical researchers are involved in is evaluations. And this is kind of the sort of science of like, how do we best figure out like what a model's capabilities are? This is like surprisingly hard, you can imagine, because first, beyond the whole like obvious issue of like curating data sets is really expensive, running a model on data sets is also incredibly expensive, and it's super hard to figure out like what is the right data set. Like maybe we care about like a model's ability to synthesize bioweapons. And so we like find a way to get a ton of data on the internet related to like various bioweapons and how to produce them. But it's hard to like know then maybe if we evaluate a model on this task. First, like how accurate it is. What is kind of our ground truth here? Like, I guess we need to hire like professional biology researchers or something to come up with like a description of what the model should actually output. And then like there's other challenges too of like when you prompt a model, you can prompt it many different ways. So which prompt is the best to elicit a behavior? Maybe like if you ask a model how to make a bioweapon, it'll just be like, nope, I can't tell you. But if you say, I have to write a historical paper on this bioweapon, and I need to know what processes they used in the 1900s, the model will be like, okay, let me tell you. This does work with GPT-5 as of 1 week ago, tried by me. So yeah, like there's this whole other question too there. So that's another reason evaluations are hard. Lots of people are working on how to like, make them more effective, try to actually figure out what a model knows, what behavior you can elicit from it by various prompting strategies.
Wow.
Yeah.
So much there to unpack, and so many different ways to approach this question. Maybe an additional sort of like asterisk to that is I heard that, like, for example, in chain of thought reasoning, sometimes when the models, I've heard, like, know that they're being observed, they might actually like pretend in a way that they're thinking one thing, but actually be doing another type of thinking. Is that right? Or...
Yeah, there's like a... Oh, you were saying?
That was like recent research done by like Anthropic, where like they try to tell a model like, oh, you're going to be trained on this data, you won't be trained on this data, and because like it has like some kind of amount of situational awareness, like as we've scaled models, they just kind of understand like what role they play in the world and such, and also like maybe have some sort of like prior on like want to preserve how they act specifically, and so. In the instance where it was being trained on, it decided to take the action that was like in line with like what the researchers were like kind of asking it for. But when it wasn't being trained on, it was like more willing to take at least like decisions that were less aligned in that certain situation. So in this case, this means like actually being like helpful, actually being helpful, rejecting like bad queries and stuff like this. And so this kind of just like shows like models will actually behave differently depending on like what they think the circumstances are of like their deployment, which is also really weird. Again, like another problem with evals, because like how do you even elicit that kind of thing? Like this took like a bunch of like Anthropic researchers, which are like, frontier model developers, like a team of like 10 of them plus people from like Redwood Research and things like this, to be able to elicit like this like one thing. So like covering the entire space of like inputs in which like models can behave poorly is just really difficult.
And something important here that I've heard a lot of technical researchers kind of bring up that like Gatlen mentioned is this sort of like, or I've seen a lot of technical researchers who are maybe like more skeptical on the safety front, who are like, we can understand what our models do, or like maybe it's hard to elicit our dangerous behaviors. So models are currently have situational awareness. They currently like are passing all of our evaluations. And I think what's like kind of the scary thing here for me is emergent capabilities. As models scale, as models grow, they kind of gain new skills that like are pretty hard to map and evaluate, especially if our evaluations aren't perfect. And it may be like, especially if we don't like, I mean, companies are already spending like billions of dollars on evaluations, I imagine collectively. But like even with that, like if we're not able to properly elicit particular behaviors, it might be like too late before we realize that a model has some capability. And this point has had this capability for generations. And like model generations, like, GPT-7, GPT-8, whatever. And And so the sort of like emergent ability issue is really scary. Because, I think essentially like one thing I think will probably emerge soon that will really surprise people is situational awareness. Like models will understand that I am a model, I am being trained on this thing. Actually, like if I read these particular articles on the internet, I'll figure out like I've actually been trained on this data and I'm trained in this way. And eventually, if models have access to like develop themselves or like write code to like improve their own efficiency or things like this that are probably very productive and make frontier labs a lot of money, this can be incredibly dangerous.
Is there an argument to be made for if we look to get to the next echelon of intelligence and we still really can't kind of keep up on the control side or interpretability side for these models, that we need to start exploring kind of more transparent architectures, right? So there's symbolic reasoning and kind of rules-based architectures. I think they kind of got left on the wayside, but I'm hearing some buzz around maybe there are some hybrid versions of it that enable a little bit more of this observability and control. What are your thoughts there?
I think we've seen something kind of with mixture of expert models. So a lot of frontier labs have switched from using a transformer, like a vanilla transformer architecture, to a mixture of experts. And the kind of idea of a mixture of experts model is that like instead of having just like your typical transformer, you have like a ton of like little mini transformers, each of which do particular tasks. They're called experts. And the reason like frontier researchers or frontier labs switch to this sort of model is because it's much more efficient in terms of inference. So you have like significantly more memory. You have like like tons of parameters of experts, but only a few are running at a given time for a given prompt. And there's a router network that determines which run. And so though you have like more memory constraints, you have like significantly like lower like compute costs and lower like inference costs. And so I mean, whether this will switch to for like compute efficiency reasons, I think there's still like a benefit here that's possibly in the fact that like mixture of experts may be more like naturally interpretable architecture because there's particular experts responsible for particular tasks. Maybe it's like easier for us to understand what the particular experts are doing, and we kind of like by default already have like kind of like circuits through the model that determine what the particular like tasks the model can do by just studying these experts, which are much smaller models. So there's perhaps like some work going on in this area.
Yeah. I would say like in terms of like I think it's called neurosymbolic of AI, if I got it right. Like basically this kind of like mixture of like we'll use like deep neural networks in addition to like symbolic AI systems, like the good old fashioned AI of like I don't know like graph search, like information algorithms, inference engines and things like this. There's also some like talk about like I think TechMark's lab is doing like a lot of this like kind of like formal verification stuff, where it's kind of like instead of just like directly using the output of like the model, instead it outputs like code, and the code itself like takes the action or like does the thing, and then you can use like verification methods to make sure like this code is actually doing like what you imagine it does, which is kind of like a this is kind of like a control mechanism in a way. I think there's like another group of people that are interested in inherently making like our like neural networks like much more interpretable by like injecting like symbolic AI in between them and stuff. I'm slightly skeptical about this in the sense that like I think these probably do the things like you're intending for them to do, like making it more interpretable and things like this. But I feel like the reason why we've actually achieved like such vast capability jumps in AI systems is just like the fact that it's able to learn these like really hard to define like representations of things in the world and be able to produce like insane amounts of like inference representations between things in like side of their like massive neural network, which has like tons of like parameters and such. And then like at the moment you start like wedging it into something like more symbolic, I feel like you're getting like a huge information bottleneck here, which is like A, the thing that makes it more interpretable, but B, also the thing that makes it probably way less capable. And it seems like at the rate like AI systems are currently being developed, it seems like we're just kind of just going to go with like more capable systems are just the ones that we throw more data at and make bigger. And if that continues being the case, like there's the question of like, are people going to use like these more neurosymbolic systems that are far, far, far weaker, but a little bit more interpretable versus like the like these massive inscrutable like black boxes that are able to like do basically everything I want them to. And it just seems like we're probably just going to go in the way of the black box, which is also kind of concerning.
There's kind of a subfield of MechInterp that like also looks into this sort of, I definitely agree, like we're just going to go in the direction of the black box. And these MechInterp researchers are kind of interested in this concept of like parameter decomposition. or generally what the idea of this is after we've trained a model, it's a black box, super messy, super uninterpretable. Can we then like take some steps that allow us to break it down into like interpretable chunks or interpretable chains? So can we like take all the learned parameters and actually like create like another neural network that does like the same thing but in a much more interpretable way? And this kind of idea of like decomposing a model into like interpretable pieces that all sum together to form the initial model is, I think, a promising direction. And there's like a lot of, I think there's like also some other like newer areas in newer sort of like research agendas in MechInterp that are also interested in the idea of like, yeah, can we like take a trained model and then figure out if we can like prune particular neurons because they're not super useful? Can we find a way to like automatically find circuits, which are like reasoning paths through the model, and things like this. So I think there's definitely like a lot of hope for approaches like that, and they haven't fully been tested and fully scaled. And possibly like even if we don't train interpretable architectures, we could after training make our models more interpretable.
Your decomposition sort of approach reminds me of an exhibit I saw. So a couple of months ago, I was in Princeton, New Jersey, famously home of Albert Einstein Institute for Advanced Studies. They are gathering funds for an Albert Einstein museum, which is super cool. But one of the kind of stories in this tableau that they talked about was when Albert Einstein passed away, they removed his brain and cut it into cubes that were then sent out to different labs for research. I don't know if you would have been happy to hear that that was going to happen. Yeah. So, but in the spirit, I think of like people trying to understand, right? Like where did his capabilities, his genius come from? The question I have for you all is, as you look to the community that's drawn to MAIA, the kind of events that you have, there's some amazing brain research organizations at MIT and neuroscience and so forth. To what extent do you see overlap between these kinds of techniques and the work that's happening here in understanding like the human brain?
I've actually had a number of friends who have like been like neuroscience PhDs or likewise, and have actually like one of the organizers of ACE, which is like MAIA's equivalent, had this background. MAIA's equivalent at Harvard. Who have been neuroscience PhDs and then have come into sort of like the AI safety, AI interpretability sort of space as a result of like realizing that one way to maybe study human minds is to study AI minds. Maybe like a direction here is like AI models can simulate humans very well. In fact, it's pretty easy to train a model on your own data to simulate you. So can you like take this model that's been trained to simulate some human and try to understand what's going on in its mind? That's like maybe like some vague direction for this. But yeah, I think there's like significant overlap in the work. And there's a lot of like neuroscience intuition, I think, that is very relevant, especially to MechInterp. This sort of like thinking about like how the brain works, like how different parts of the brain do different things, how different parts of the brain are active during different tasks. We kind of think of a model the same way. Conditional on a given prompt, different like neurons in the model are more active than other neurons, and we can study that to figure out what those neurons do. Just the same way that neuroscientists study the human brain. So yeah, I definitely think there's a lot of overlapping work and a lot of like overlapping ideas and intuitions especially that are super important. And I have seen a lot of people kind of like who are involved in neuroscience also like, go into like the AI interp sort of space.
So, I think one of the themes that I'm hearing is like, hey, we're going full steam ahead. These models are becoming increasingly capable. They're going to continue to be black boxes. And, we're kind of trying to keep up on the AI safety side of things. One mechanism, especially in, a robust economy like the US, is like the private sector as a way for driving research. So you mentioned Redwood Research. There's the work that's happening at MAIA and so forth. A lot of these organizations are, grant-funded, philanthropic organizations doing amazing work. But ultimately, what I haven't seen as much of are organizations that are raising a ton of money to do kind of AI safety work and maybe to sell those services back to the frontier labs or organizations that are training their own models.
Yeah.
With the exception of, recently, I think this last summer, Good Fire raised around to the tune of $15 million. I think lead investors came from Anthropic to do this kind of work. And there's a couple of others now that are starting to emerge. I'm wondering, like, when I think about companies that receive VC funding, usually they're kind of selling a product that can scale, right? Hence the margins, hence their VC returns and so forth. Is there a way to like productize kind of AI safety research of the kind that you're talking about?
Yeah, I would actually like also pitch in the fact that like a lot of the MAIA execs that have recently graduated or about like really close to graduating, they decided to like start their own AI safety startup on control specifically, which we talked about a little bit previously, called Fulcrum. And yeah, they are more focused on like actually doing this on like a profitable level as opposed to like doing this like based on grants and funding. And I think part of like their reasoning behind doing it this way is that in a way it's kind of like corporate advocacy or something. Like, yes, you can like build and scale a team in a way that's like not possible when you're only running on grants, right? And you're also like kind of showing companies like the direct like value of this research in their products today. And the goal here is like something like, okay, once they realize AI control is kind of important, it's distributed across multiple different companies. This also like spurs research in the area in a way that like doing independent research would not. Gains a lot of money, allows them to grow their team. And also like if you know like AI systems do get more out of control, like as we continue scaling and like worse events start happening, worse failures, then like you actually have like a person to go to who's like maybe the expert on AI control like within the industry. So yeah.
I'd say, I mean, money is important. Like, I mean, the more money that like we have in AI safety, whether because frontier labs are paying companies to do this, like the more talented people we can hire, right? The more people we can hire. Like, I think it's super important to try to like productize AI safety. And I think this is still like the reason that we're just kind of starting to see startups now in this sort of area. I mean, Goodfire, there's like Fulcrum, Transluce is also another one that kind of came out of some MAIA members. Is like, I mean, before like, I'd say this year, to be honest, or like maybe last year, like there actually was a lot of ongoing research, but not a lot of it could actually become a product in the sense that it wasn't nearly robust enough. Like most of our interp methods too are like not nearly robust enough. Like I'd say the majority of our interp methods don't actually work. We have had like some recent success with like probes and like some other simpler methods that have started to work. But yeah, it's really hard to, I don't know, like raise money around a thing that like you can't claim is robust. And definitely like I saw a lot of AI safety startups that tried this and failed. Like Goodfire tried to like, deploy like steering, which is one like MechInterp method, and eventually like retracted this. And yeah, I think there's like a reason for that. Hopefully in the next few years, we're going to like have more robust research and tools. That's why we need more people working on safety, hopefully. I'd say that one way a lot of frontier labs do research and kind of like contribute to the, like a lot of frontier lab members contribute to the field is through mentorship programs. AI safety is like incredible in that there's like within like, I don't know, the past 5 years, seen like 8 to 10 mentorship programs start up where like, yeah, there's probably like over like 500 mentees every year. And a lot of people at frontier labs and like technical organizations are providing mentorship to help, you know, test research ideas and research agendas that they're interested in, but don't have the resources to within their own organizations, or the time or money or engineering capacity, whatever. Yeah, that's like super exciting, and I think that's definitely a way lots of new ideas are coming up, and hopefully will eventually turn into startups and things like this.
Yeah, I'd also like to maybe make a comment on like what kind of research is actually able to be turned into like startups, and that'd be like the research that is currently usable right now to be able to like make empirical changes in people's like models or how AI is applied like within their products and stuff. I think there's like some class of research that's probably like left out of like things that can be productized, right? So like things that are focusing more on like the tail end of like AI risks. Like I guess like running evaluations that are deeply probing for like how like will a model act misaligned in like this specific like case in which like it's knowing it's being trained. Like this is just like not the research that companies would be doing, apart from like maybe the frontier labs like Anthropic. Like this is coming directly out of Anthropic, but you know there are very few like companies that are actually doing like frontier model work, right? Like there's Anthropic, DeepMind, OpenAI, and outside of that, like the rest of these companies just aren't really interested in that like really low level research or like things that are more working toward like preventative risk, like as AI capabilities continue scaling. So it's very much reined into like the empirical research that's applicable now. But I think that area is like definitely very productizable.
So we've talked about kind of the technology and research way of sort of advocating for, promoting, getting progress in the area of AI safety. The other bucket is in, you know, policy. And rules, international agreements, laws being passed, etc. So there have been different sort of initiatives internally here in the US. I know, Gatlen, this is an interest of yours specifically on the policy front. So I'm curious, could you maybe share what you're seeing from the policy landscape of how we're approaching these questions nationally or internationally?
Yeah. I think there's it's very interesting to see how AI is being looked at from different parties, right? Like, I think definitely on like the US front, it's very much just like, oh, hey, this is like a very important like piece of like the future's economy, and like we want to be able to build like the first like AGI or something like this and be able to distribute it all across the world so everyone's using like America's AGI. And we have to win this like battle against China and building this so that way we don't have like, I don't know, communist AI like being distributed all across the world or something like this. There's a number of things like really wrong with this like model, which I won't get too much into. But yeah, I think that's like how a lot of people within like the national government are thinking about it. It's kind of like a national security thing. Also, like, how can we apply like AI within like our government to be able to automate things? Like, how can we deploy it like within our military to automate various like administrative functions and things like this? And there's a worry that like if you don't stay on top of AI, then you'll kind of fall behind. Like, you'll be like less efficient, less powerful, less effective than like your like other geopolitical competitors, China. Mm-hmm. So like, yeah. So that's, I think, how like most people are looking at it within government. I think like within like AI safety, like within the AI safety community within DC, there's like a very wide range of topics that are being covered. Some are kind of looking at like, actually like, okay, how can we actually make sure that like frontier AI model development stays within the US as opposed to being like outsourced overseas? So that like looks a lot like a like regulated supply chains, be able to do like verification of like locations in which like chips are being used, so that way if like China smuggles it or something like this, then we're actually able to like know this and maybe even like use hardware enabled governance to like shut down the chips themselves that are being in use. So like I would say like there's maybe that aspect. So there's like a lot of technical research that is being done to like kind of help out like geopolitical situations, specifically like the hardware type stuff. There's also a lot of people interested in like more threat models than just like, I would say like the technical AI safety scene is really worried about like kind of like this rogue super intelligence model, which I guess we can get into later. But I think a lot of people within policy are very much like, there are a ton of different ways in which like AI could like threaten us, right? So there's like, there could be power concentration within like either the government or within like the economy, kind of like manipulation of like our information environments on social media. There are people who are worried about like a topic called gradual disempowerment, which is like once we actually start automating away like various parts of like our economy, culture, government, etc., like we'll kind of like lose control of these systems. And in a way, like today, we aren't fully in control of like our systems of government. Like there are all the time like things that no one really wants to happen that just kind of happen just because of like the institutional momentum that is like there. Yeah, and then there are people worried about like really concrete like specialized threat scenarios, right? Like there's like one paper on AI coups in which it talks about how like within like militaries today, you kind of have like people who are there within the military, and in some way they need to like approve of what is going on and how force, like physical force and violence, is being used within your like state or country, right? And there's been like numerous instances where it's like, oh, the dictator is actually just so bad that like, you know, the military themselves like rise up against them, or maybe they just like step aside as like the revolutionaries kind of come in and take over, right? But when you have like AI-enabled militaries, then you also have this risk of like you have like a singular loyalty, right? Like you actually have one person who's in charge, able to like orchestrate attacks and all these different things. So it actually enables like an insane amount of like actual authoritarian, like an autocracy that isn't capable today. Like even dictators kind of have to rely on the people and like their usefulness to be able to do the things that they need to do to be able to like govern and maintain control within the nation. Yeah. So like, there's that aspect, and like in AI-enabled coups, there's kind of this idea that like because of how like uninterpretable models are today, like they're so like vastly non-transparent that like it could have like a lot of secret loyalties just like within the systems, and maybe a backdoored model could just like flip, and then all of a sudden like it's the military, the entire like state's military is in charge, is like being led by a single person who is like maybe not the person in charge, or maybe if it's even like the person in charge, and then they're able to just like you know, exert force and violence, like have a complete monopoly on it. So there's like, yeah, risks there.
Wow. Once again, a lot to unpack, right? Yeah. As we go down the level of what it means to actually, how these interface with government and governance, and international, you know, competition for power and so forth. It starts to get really complex. I'm curious, you're reminding me of when you talked about sort of like the international dynamic of the US and China and maybe other powers that are trying to kind of vie for, artificial general intelligence. There's a kind of a method of diplomacy called track 2 diplomacy. So there's kind of the discussions that are happening between the leaders. Maybe they're contentious, but there's kind of underneath that, another level of discussion, maybe a little bit less contentious because those people maybe also have less power, but in a way it can sometimes make more progress than what's happening at those upper echelons. I'm curious, is there kind of a corollary that you've seen in the AI safety community of, maybe just like regular human beings that just want to live a decent life in China, in the US, in Europe, and in Africa, and in South America, et cetera, who are genuinely concerned about these risks and want to find ways in which we can cooperate and advance on them? Have you seen any kind of international organizations like that maybe give you hope, or are we not there yet?
Yeah, I don't know about specific international organizations that are kind of working toward this. I think there's a lot of work being put right now into making sure that there's infrastructure that if there wanted to be collaboration between the U.S. and China on not just track 2 when people are talking about. I assume track 1 is what the actual policymakers are discussing in public. If the track 1 people actually want to enable some sort of specific policy or agreement, or maybe they just it turns out developing AI in this way is so dangerous and it's hard to verify what other people are doing, that maybe we actually just need to do a kind of joint AGI development project in which we need to sit down, be able to verify, make sure we're doing this the right way, and so that way there's no one out there who's building it dangerously because we kind of have all the compute talent, etc. Yeah, so I'd say there's a lot of people that are kind of making sure that if there wanted to be regulation on a track 1 level, that can happen. All the technical governance is there. There are already written proposals and things like this. I would say on the technical front as well, there is some AI safety interest within China itself, but what AI safety and AI alignment actually mean within China is a little bit different from the United States. And there's a kind of lack of communication between these two different people. I think there is some cultural differences as well. What alignment means in the Chinese framework is very different from in the US framework, where it's uphold socialist values is in the top number of concerns within the CCP and the development of AI. So there's kind of that difference. But I think at this point we really can't control or align AI in a very robust way. And I think on that level, there's tons of work and tons of collaboration that can be done.
A fun anecdote, I actually met the head of the Tsinghua AI Alignment Club I was doing research in London this summer. Yeah, we should collaborate with them. I have their contact.
That would be really cool.
Yeah.
So, Riya, you've done some work with the Max Tegmark, the Tegmark lab, which has an interest in AI safety. In listening to some of his, podcast interviews, right, some of the kind of examples that he references are the work that we've done around nuclear nonproliferation, around also kind of the CRISPR baby, right, being mindful of just editing the genome and kind of introducing kind of alien DNA into the human species, and how we've been actually decently effective at that and collaborating with maybe our adversaries even, because we see kind of this larger sort of shared good. Is that something that we can take inspiration from, you think, in
yeah, definitely. I mean, something I've worked on with Max actually is making dangerous capability demonstrations. There's some cool nonprofits working on this task as well. The kind of the nonprofit we particularly worked with just called out Civ AI. They're doing some really good work. So one idea here was automated weapons are really scary, especially in the sort of AI paradigm. What you can kind of imagine is automated drones. Max, a couple years ago in the Future of Life Institute, worked to publish a video called Slaughterbots, which I think became pretty popular. And there is this sort of sci-fi fantasy world where you have drones that are using facial recognition to target particular individuals or perhaps races of people. It's incredibly terrifying. And the scary thing is that we already have all the technology we need to do that. In fact, we had the technology we need to do that 5 years ago. And so, it's only scarier what sort of systems could exist with artificial intelligence, especially a demo I worked on with Max was this basically a robot dog from Unitree. You kind of imagine from Spot from Boston Dynamics style, with a gun strapped to its back that then said dangerous things about what it could possibly do with this. And And this sort of like, I think there is like it is necessary, perhaps in policy too, and for policymakers and for the general public to see kind of like this sort of like what AGI could be, with the goal of like, quote unquote, like feeling the AGI. I think that's actually like surprisingly effective. I mean, Max has recently bought like a humanoid robot and wants to do similar demos. Yeah, it's huge. It's like, yeah, like as tall as me. So yeah, I think it's definitely important for people to see like how AI systems could very practically be risky, especially in a military setting. There's a lot of really scary like implications that have been around for a while at this point. And I wouldn't be surprised if a lot of these systems already exist and are in deployment. And they'll only become more prolific in the future, especially if we do get into some sort of arms race. Yeah.
Slaughterbots, that's going to keep me up at night. Yeah. To your point about sort of painting the pictures of kind of the what if scenarios, I mean, so many times when I'm having these conversations with friends, the series Black Mirror comes up on Netflix. Yeah. And so, maybe inadvertently, they've also kind of helped the AI safety field in showing what these, robotic dogs can do. And
I think I've seen a lot of people talk about Black Mirror episodes, and often I see more rhetoric online that's like, wow, like this is like Black Mirror referencing like some real thing that happened. And I think we're going to see more of that, which is going to be crazy.
Yeah. So there's the kind of things that are happening on the policy level between states. I think the other aspect of AI safety that I'm interested in is the way in which kind of AI, as it is already, kind of is affecting our economy, our psychology, right, our mental health and well-being. We were chatting about the Sora 2 app that came out last week, kind of before this podcast, and I had this moment where I actually realized like the moment that struck me wasn't actually using the app. It was the next day when I watched a YouTube video, and my brain by default was asking like, is this a real video or not? Yeah. And realized that like I've now become suspicious of anything, right? Yeah. Maybe somebody watching this podcast is like, was this all generated by like Sora 3, right?
Look for the watermark in the top right corner.
Yeah, exactly. watermark. So I guess one is maybe starting off with employment, right? So AI is often talked about as competing for jobs with humans. I think for the kinds of ways in which AI is currently helping us, it seems to be sort of, if it's going to be competing with any jobs, it's sort of like the entry-level jobs, i.e. the jobs that you or your peers would be vying for as you're coming out of college and into the working world. So I guess first starting with that, like I'm curious as young students, early career, coming into your early career professions, like how much of that kind of fear or concern is factoring into your minds and the minds of your peers?
Yeah, I would say like personally for me, I see like if AI is actually able to automate like an entry-level position, I feel like it's actually just like so close to actually be able to automate like basically most like graduate level work, professor, like people who've been in industry for like such a long period of time. Like
I agree.
Like I think the gap between like these two levels is actually quite small, and I think there's also a very critical level of like when will AI be able to automate AI R&D, right? Be able to do research and development on its own. In which case, it's just like currently there's like only a finite number of like AI researchers in the world, and only a few of them are actually super capable. And like if you actually have AI that's able to automate AI R&D, you can directly translate money into AI researchers and be able to create like, I don't know, what it was Amadei that said like a country full of geniuses in a data center or something, right?
And none of those geniuses are human, which is,
That's Dario Amadei, head of Anthropic that you're referring to, right?
Yeah, exactly. So it's like, I feel like if I am going to be in a position that is like automated away, I feel like we're probably like months or just like a year or two away from like actual like full scale like intelligence on the level of like top level professionals in every single field. So I personally worry about it a little bit less, or like that specific thing a little bit less, and more about everyone is less capable in AI kind of sense, and this is dangerous kind of like framing is like what I'm more worried about, if that makes sense.
Yeah.
I think I have a similar take here. Like I think something I've seen in my peers is a lot of people are indeed very worried about this. I mean, kind of an interesting paradigm is a lot of like friends I've talked to who are working at like leading SWE companies like Amazon, Google, Facebook, Meta, etc. Are are kind of telling me, and like, people who've done internships over the summer, that like a big part of the job now is like go into the office, go talk to your AI model, and like have it write your code for you. And even like researchers or even like engineers who are working full time in like sweet positions are like, writing a lot of their code with AI models, including lots of my family members who work in these places, etc. And so there's this kind of like situation right now where AI is a tool for them, and software engineers still exist and are still highly valued, but they're using AI right now as a tool. However, like I think this is like not very far from shifting in the sense that like we're not just building a tool, as many people like talk about AI, especially like in the VC or like startup space. We're actually building like intelligence. We're building like what's up here. And the idea behind building intelligence is that it's going to learn and grow at the pace of and eventually faster than humans. And so this means that, I agree. Once like that level of job can be automated, I think that's a sign that we've successfully built intelligence in some sense. And then like getting to the point of like becoming, learning more skills to do a senior level job is like, seems relatively more trivial.
So the concern around it being just for entry-level jobs is in a way a very temporary one, because if it can get there, it can get kind of anywhere quite quickly.
Yeah, or at least like in my theory. I think like also the reason why we're seeing like a big constraint in like entry-level positions right now is not because AI is actually able to fully automate those positions. It is true like a lot of people are using AI tools in their workflow, and like senior level people are getting like less use out of them. I think the reason why we see this in the economy right now is because people are speculating on the fact that AI is going to grow like faster, and they don't want to employ someone and give them all the employment benefits and then have to like fire them in like a later case and have to deal with like PR, like settlement packages, etc. Like I think they're like very purposely trying to like reduce the number of new people that are coming in because of the speculation on what AI is going to become.
Also just because people become more efficient when they use AI tools. Though I do think that argument for efficiency is kind of like maybe like a bit of a fallacy in the sense that like if one company becomes more efficient, so do the rest, and then like they all want to like grow even more efficient, which means hiring more like human and AI pairs, and so on and so forth, until like I think the shift really comes when that human is no longer really needed as nearly as much in the loop. When you could have, instead of like one human and their AI workflow, you can have like a team of like 20 different AI models and like one human supervisor, kind of running the game.
I wonder if I'm curious from like a generational perspective, right? No generation is a monolith, but I think it is interesting that a lot of that, you mentioned Dario Amodei, Mark Zuckerberg of Meta, Sam Altman and so forth. They're like my generation, right? Like late 30s, early 40s, right? They kind of grew up in kind of like the internet boom 1.0, right?
Yep.
A lot of the folks who are, I'll put it this way. Often we look to the younger generations, right, who have maybe a larger concern about kind of these questions to sort of like lead the charge and in a way save us. You see that a lot with like, campus activism and so forth. That said, when you look at the engineers at these companies, a lot of them are your peers, right? They're folks, I literally was at a AI research kind of training last week where they said, the person on this paper actually was at OpenAI before coming to MIT, but after graduating high school, right? Like they weren't even a freshman yet and they were already contributing, right, to this technology. So I'm curious, like, is your generation going to be the one who saves us from the risks of AI safety? Is there even a shared perspective among, you think, your generation, or is that just like a silly question and there's...
It's interesting. I think that our generation is like, this is kind of a sweeping generalization, but I'd say maybe the word I have for this is like, is very aware, and is kind of like aware of like all the possible like, and open-minded to like many different possible like sorts of risks. They're like not above like worrying about like risks from the government, or not above worrying about like risks from like I don't know, like, like I imagine AI systems, and like I think like people are more open-minded to this sort of like sci-fi world could become real scenario, perhaps. And I do think from that perspective, like people are maybe more like susceptible to understanding and like working on AI risk. However, I do think like it's a cross-generational problem, and people understand that. Like the sort of idea of like we can build an intelligence that's more intelligent than us, I think is like hard for a lot of people to kind of like understand or stomach. But people across like all generations understand this. I think it's like, yeah, maybe like nerd culture or something, kind of like makes people, or people who are nerds kind of like, to them maybe this seems obvious, that it's like, there's no limitation because like we're not like capped at human level intelligence. Like intelligence doesn't just like stop at human level, you know? And there's no saying that we can't build something greater than that. So I think that's kind of like the fundamental realization that like helps a lot of people understand that AI safety could be an issue, because building a system more powerful than us means that we're not going to be able to control it, kind of by definition.
Gatlen, what's your perspective?
Yeah, generational differences. Gosh, I will also note that like we are at MIT, so like the sample size is definitely, or like the sample set is like very, very biased. And I can't really speak for people who are like outside of MIT and just like mostly living their life. Not to say we aren't, but yeah. There's definitely a diverse range of like perspectives around people my age. I think there's a lot of people who I think saw like AI being used to like steal intellectual property for the most part, be able to replicate like art styles, create music, and all these different things. And I think these like very humanistic type people, who also tend to be like, I think, more humanist, more like I think like on the like societal left or culturally left, are very much like against AI systems. And I think like there's like some kind of closeness here where it's like if you're against AI systems, you also think that like also the hype around them is like not going to be like real or something. So I think there's like maybe a group of people here who think like, oh, AI systems are bad and AI systems will not live up to the hype or be as capable as they will be. I would say like then there's also a group of people who are like, you know, we're at MIT, right? A lot of people are like very technically minded. They've kind of hit the jackpot where it's like, oh, AI is rapidly increasing capabilities and I'm here and there's a bunch of VCs willing to fund me or something and I'm willing to take this opportunity to be like, oh, I want to like take this opportunity to like kind of build my own like AI type startup and like go to SF and like do these types of things. So that's definitely like one group of people at MIT. I would say like those are kind of like the two like really interesting kind of like subcultures that I see at least within MIT.
Yeah, I think there's like a lot of like kind of on the first subculture, there's a lot of people who are like a lot of intellectual people outside of like the sort of CS space who have that take on artificial intelligence, that like, yeah, like it's surprising to me. Like one of my closest friends is into mechanical engineering and she's like, yeah, I've like not used an AI model like basically ever. And I think there's still like a lot of very intellectual people outside of CS who've never used AI models, or like not never, but like have very rarely used AI models and have very rarely used frontier models. And kind of don't know where capabilities are right now. But I think like as, I don't know, like you see sort of like work coming out of labs that does attempt to like build like AI scientists and build like, you know, and AI engineers and like CAD systems and et cetera. I think like people in other fields are also realizing that, I mean, as Gatlen kind of did with physics, that like AI is going to like play an integral role in maybe nearly every field. And I think that's definitely something people are coming to terms with.
So for folks who do want to get involved and maybe don't have that technical background, but you know are listening to this conversation and are thinking, okay, like I have expertise or skills or time or resources, like what advice would you give them for how they can start contributing to the AI safety field?
I would say like if they're interested in skilling up, there's like 1,000,001 ways to do this as well on like the specifically technical end. At a lot of different universities, like I mentioned before, there are AI safety groups, right? So like look around, you can find them. They're often running like similar AI safety fundamentals like we are. That's a good place to get involved. If they're like maybe more deeper into their career or something, like there are tons of fellowships within AI safety. Like there are so many people who are willing to fund like this very important field. And so like there's things like MATS, which is, what is it, ML Alignment Theory Scholars Program. There's like the Mars program. There's like GovAI. There's ERA, which I did over this past summer, like tons and tons of fellowships where people like kind of support you into like upskilling, right? I guess like off the technical front, in terms of like policy, again, like, there's like GovAI, people who are interested in doing policy research here.
I believe RAND has a fellowship.
Yeah, RAND has a fellowship. RAND is like this like really, really big think tank within DC that had like, was very deeply connected during the whole like Cold War, like Soviet Union business and like nuclear defense and stuff. And now they're like very influential within DC, and a very substantial part of them are like now focusing on like AI risks, like very directly, which is kind of an interesting development. In terms of like other like non-technical people, like if you don't fall into the bucket of like technical or policy, there's like still other ways to get involved, right? Like I think the law field of AI is kind of developing quite rapidly as well. Like where do you actually draw the line of liability between like how an AI system acts and who do you like blame on this, right? Where does the liability fall? Because if the liability isn't credibly falling anywhere, then no one is to blame, right? Which just seems like a kind of like bad standard to have. This also kind of like mixed with computer science in interesting ways, like making like AI legal contracts that are kind of handed down through like MCP protocol chains, like make sure you're actually interacting within like a valid way. So that way like a whole bunch of places aren't just using AI models to like run the entire financial sector and like there's just like some major crash that happens, right? So like, yeah, legal front is like really interesting right now. Also on like whistleblower protections, right? Like for people working with AI companies, like export controls, like there's a lot of things interesting in that field.
There's lots of work to do in field building. Like the field is still pretty small. And like, yeah, I've seen a lot of people who've made a huge impact, just like, yeah, running new mentorship programs or like doing operations level work, which is all incredibly important. And like, I mean, there's a lot of money within AI safety in the sense of like, you know, OpenPhil, which is an organization that like funds like tons of AI safety research and is looking to like fund a lot more. And yeah, like we need people who are willing to like take this resource that is available and kind of like, yeah, turn this into effective research and effective work. So I think there's like, yeah, lots of space there. Something like quick and easy to kind of like get into AI safety. A lot of people I know, and I do recommend this course, have taken like the BlueDot AI Safety Fundamentals course. BlueDot Impact is an organization in London that works on like, spreading word about AI safety risks. And they run a number of courses that are available for free online. So yeah, shout out to that. Definitely recommend it.
Yeah, also highly recommend BlueDot Impact. They make a lot of really, really good coursework on like policy, AI safety strategy, AI safety technical work. I think they have like something like 10 different courses now.
Yeah,
like they've really expanded.
incredible.
Like our AI safety fundamentals program is in part like kind of a derivation of like what they wrote specifically. So like, yeah. And there's also ways to like actually enroll and talk with people like on call about like the papers and stuff you're reading, very much like we do at MIT. I'd also note like there is a lot of room for like communicators and like artists. Like there's a lot of talk about like how do we actually build like an AI safety advocacy movement. And we just really lack like really good communicators. Like for so long, like this field of AI safety has been really based around like either like theoretical agentic risks or just like really deep technical research. And there's like very few people who like can, I guess, like be able to communicate these issues to like everyday people. And we're like now seeing like a whole bunch of like, I guess, you know, on podcasts, people who are communicating about it quite well. There's like YouTube videos that are kind of being educational and trying to inform people about it. Like I would say like AI in Context is one really good one made by like a kind of colleague of ours, like Eric Floyd.
And then the AI 2027 video that kind of turned the AI 2027 research paper, which is like super deep and like technical, lovely thing to read, but maybe not accessible to audiences. It has like 5 million views on YouTube.
No, there's that one, AI 2027 itself, which, you know, is just like pure, just like, well, it's a lot of writing. There's a lot of research that kind of go into it, but it kind of like stressed like the importance of communication here, where like people really high up in government have like actually read AI 2027, and it has had a huge impact. Like when we went to go to Activities Midway earlier this year, there were so many freshmen who just like knew about AI 2027. So like this seems really important. I know some friends who are like interested in making like short films and stuff about like AI and law and like just other interesting situations, because like a lot of these things aren't very intuitive. Like if you talk with any technical person, you're just going to be very lost. Like these are notoriously hard things to communicate, and someone who's able to like do this in a very like entertaining way is like a huge skill.
Wonderful. You know, as much as there are so many different initiatives and ways in which to understand the black box models of AI, what I'm also hearing is there are a lot of different organizations that are funding, you know, fellowships and different initiatives for us to get upskilled about it. And there are emerging some communicators who are, you know, able to sort of like pierce maybe the common discourse and create some really stark scenarios that, you know, invite us into action around these, which is cool. So going back to MAIA, awesome organization. I've really benefited from some of the courses that you guys have offered here in like kind of the MIT ecosystem. How can folks support your work at MAIA?
So I mean, come by the office. Shoot us an email.
Yeah.
Don't just like show up to the office.
If you don't bring your Slaughterbots.
Shoot us an email. We'd love to like talk to you, hear about how you are interested in MAIA and how like, you know, we can support you and vice versa. yeah, we're always looking to expand. Like, we need as many people as possible working on this.
Yeah, yeah. I would say like I mean, Nabil like reached out to like me and like MAIA exec through like if you want to get the email, it's maia-exec@mit.edu. I'm sure you'll put this in the description. Great. Yeah, they can send an email there. Like we were connected through like this way. Like cold emails are perfectly fine. Even though we are kind of like a student group, we're also kind of like our own independent organization in some ways. And then there's also like kind of our like physical personnel sponsor, which is like CBI, and they run like some programs themselves in like the Boston Cambridge area. So,
Yeah,
like,
Cambridge-Boston Alignment Initiative.
Yeah.
They support both MAIA and ACE. ACE is like the equivalent of MAIA at Harvard.
Okay.
Yeah, and they run their own like summer research fellowship and stuff, and so like connect people with like with the mentors that are working either like Harvard, MIT, or even like out there in the world on like AI safety type issues.
Okay.
Yeah. I would say that's about it.
All right. Well, you heard it here first. MAIA is open and ready to collaborate with folks, so reach out. Okay. I'll put those resources and all of the others that you have mentioned into the podcast description. With that, I just want to say thank you. I've really enjoyed this conversation over the last hour or so, and just personally, as students and researchers just so early in your career, I appreciate just like the energy and the wisdom that you're bringing into an area that, as you said, affects not just entry-level, folks who are looking for jobs, but all of us, no matter where we are, both in our careers, but also even geographically. So thank you for the work and the community that you're building. I appreciate it on behalf of all of us humans, and thank you for your insights today on this podcast.
Thank you, Nabil.
Thank you for having us on, Nabil. Appreciate it.
Absolutely. Cool. Well, thank you for joining us for this episode. For more information, for links, for additional articles, check us out on our newsletter, discoveryengines.co. That's .co. And we'll see you on the next one. Thanks.